please test the gradient of scalar function, and the following video we are going to read about divergence and curl. So let's get started. So the first question is position vectors of points P1, that is coordinate x1, y1 and z1, and P2 coordinate x2, y2 and z2 are r1 vector and r2 vector respectively relative to origin, that is O coordinate 0, 0, 0. Evaluate grad of 1 by r1 minus r2 mod, means its magnitude. So first we know that r1 vector is equal to x1 I cap plus y1 j cap plus z1 k cap, and r2 vector is equal to x2 I cap plus y2 j cap plus z2 k cap. So r1 minus r2 means r21 is equal to r1 minus r2 is equal to x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. So its mod means its magnitude is equal to square root. So now we know that grad value in Cartesian coordinate system is equal to I cap del by del x plus j cap del by del y plus k cap del by del z. So grad of 1 divided by this. So 1 divided by r1 vector minus r2 vector mod is equal to 1 divided by x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square to the power half. So when we do grad of 1 divided by r1 vector minus r2 vector mod is equal to I cap partial derivative of this with respect to x, that is I cap, that is minus half into x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square minus half 1, that is minus 3 by 2 into derivative of this term, that is 2 whole into x1 minus x2. So that is, if we solve this first term, then what we get? I cap 2 cancel out, that is x2 minus x1 divided by x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square 3 by 2. Okay? If you simplify only this term, then we get x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square half whole cube, means this term. We know that this term is the magnitude of r1 vector minus r2 vector, that is we can also write in this place as r21 whole to the power 3. So this term, this whole total term becomes I cap x2 minus x1 divided by r21 whole cube. Similarly, like this first term, you guys can derive the second term and the third term. So I can just write the answer of this question. That is, we can get common as 1 by r21 cube. In bracket we can write I cap x2 minus x1 plus j cap y2 minus y1 plus k cap z2 minus j1. So this term, we know that this term is r21 vector. It is minus r21 vector. If we write this as r12 vector, that is r2 minus r1, then x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. That is, we can also write this as minus r21. This term we can write as minus r21. So the answer is minus r21 divided by r21 cube, that is minus 1 divided by r21 square. So the value of grad of 1 divided by r1 vector minus r2 vector mod is equal to minus 1 divided by r21 square, or we can write this as minus 1 divided by r1 vector minus r2 vector mod whole square. Next question is the position vector of a point P x1 x y z is r vector relative to origin, and derive a vector dot grad vector of r vector is equal to a vector. So when we write a vector dot grad vector of r vector, that is we write this first term as epsilon I ai grad I into epsilon j e j cap x j is equal to epsilon I j is into e j cap ai into del I into x j. So we write this term as del of x j divided by del of x I, and this term can be transformed into Kronecker delta like del of I j is del I j. So when we multiply e j cap with Kronecker delta, then it transforms into e I cap into ai, that is it is a vector. So this is proved. So the next question is find the gradient of f is equal to x square plus y square, determine its magnitude and also its direction. So you guys can easily find the gradient of f is equal to x square plus y square. That is, first we take the grad in terms of Cartesian coordinate, then respectively derivate this thing with respect to x and this thing with respect to y, and then you will get the gradient of this thing, then determine its magnitude. So after finding the gradient of this f is equal to x square plus y square, the answer you find, you can easily substitute 3 in place of x and 4 in place of y, and also direction, that is tan inverse y by x. So I just tell you the answer of this question, that is grad of f is equal to 2x I cap plus 2y j cap, and its magnitude is and the direction is, if phi is the angle between x and y, then its direction is tan phi is equal to y by x, phi is equal to tan inverse y by x, that is tan inverse 8 by 6, that is it cancel out, that is it is 4 by 3. So the direction is phi is equal to tan inverse 4 by 3. So the next question is find the directional derivative of f is equal to xy plus yz plus zx in the direction of a vector I cap plus 2j cap plus 2k cap at the point p 1 to 0. So first, to find the directional derivative of f in the direction of this a vector, we have to first find the grad of f. So grad of f is equal to, so this is grad of f. So then we have to find the unit vector of a vector. So we have to find the unit vector, that is a cap is equal to a vector divided by mod of a vector, that is magnitude of a, that is I cap plus 2j cap k cap divided by 1 square plus 2 square plus 2 square square root, that is I cap plus 2j cap plus 2k cap divided by 3. So we have to find the directional derivative at the point this, that is p1 to 0. So we put this point in grad of f, that is I cap y plus z, that is 2y cap z plus x, that is j cap x plus y k cap, that is d k cap. So when we find the directional derivative, then we can write a cap into grad of f, that is I cap plus 2j cap plus 2k cap divided by 3 dot grad of f, that is 2y cap plus j cap plus 3k cap, that is 2 plus 2 plus 6 divided by 3, that is 10 divided by 3. So the answer, that is the directional derivative of f in the direction of a vector at the point 1 to 0 is 10 by 3. So the next question is find the unit vector n cap normal to the surface represented by equation x square minus 8y square plus z square equal to 0 at the point 8 1 4. That is f of xyz is equal to x square minus 8y square plus z square. So when we calculate grad of f, then we find 2xi cap minus 16yj cap plus 2z k cap. So you have to calculate the unit vector number to the surface this at the point 814. So at point 814, grad of f is equal to 16 I cap minus 16 j cap plus 8 k cap. So the value of unit vector is grad of f divided by magnitude of grad of f, that is 16 I cap minus 16 j cap plus 8 k cap divided by 256 plus 256 plus 64 root over, that is 16 I cap minus 16 j cap plus 8 k cap root over, that is 16 I cap minus 16 16j cap plus 8k cap divided by 24. Simplifying these, we can also write these as 2I cap minus 2j cap plus k cap divided by 3. So the answer, that is unit vector normal to the surface at point 814 is 2I cap minus 2j cap plus k cap divided by 3.